Hello and welcome to my channel. In this video, we will learn how to transform differential equation into a state space equation. So we have learned this in a previous video. If you want to see, you can see the derivation. I have derived all the equations for that. But someone from my subscribers, they asked to give some examples. So therefore, in this video, we are going to do these two examples. So the first thing when you want to transform from a differential equation to a state space equation is that you should understand these three important things. How many state variables you have, how many are the outputs, and how many are the inputs. So how to find that? Very simple. Just look at the highest derivative. It's third highest derivative in the differential equation. So it means there will be three state variables. So the second thing is how many inputs we have instead of output. First I want to discuss the inputs. So on the right hand side you see you have only u. So it means only one input we have. Inputs are on the right hand side. The third and most important thing is the outputs, because we are mostly concerned about the output of the control system. So what is output? Output is the solution of this equation. So this is an equation in differential equation in y. Both are the differential equations in y. So what is the solution? Solution is the value of y. So this is the output. So we have only one output because there is no y1, y2 on the left hand side. There are only y's. So it means we have only one output. So once you have decided we have one output, one input, and three state variables, then you can find the sizes of these state matrices. And this is what we have to do. When you want to go from differential equation to state space equation, what you are doing, you are trying to find the elements of these matrices. So once you know how many entries you have to find, only then you can find the entries. If you don't know how many values you have to put in these matrices, then how you are going to solve these equations. So what I want to show you is that the matrix of the size of matrix A will be n into n. So it's a square matrix. Number of variable, if the number of state variables are 3, it's 3 into 3 or 4 into 4 if n is 4. Similarly, then and the best way to memorize these things is, if you look, I have changed the colors of these. Matrix A and B belong to a state equation. So the rows of these two matrices have equal to the state variables. So both have n rows. Matrix C and D belong to the output equation. This is the output equation. This is the state equation. So the rows of C and D are equal to the number of outputs. And then what about the columns? You just write n, m and n, m. So when you are doing an exam, this is a quick way to memorize that how many entries you have to find. So now we know that we have to find 9 entries in A, 3 entries in B, 3 in C, and 1 entry in D. And let me show you about the D. I have mentioned in the previous video that D is a feed forward component. If you have a control system in which you want to put something straight from input to output, then you use D matrix. In 99% of cases, we don't want to do this because feed forward things make the control system unstable. So therefore D is always 0. Now we have to find only A, B and C. So I am going to start from in the continuity of the previous video, because in the previous video I have derived something and I am going to use this, and I promise that you can convert a differential equation into these matrices within a minute. And then for those who don't want to see the previous video, I will explain again. But first I want to directly transform from this to this and write down the entries of A, B and C. So how to do that? Basically, this x dot is something like this. x1 dot, x2 dot, x3 dot, because we have 3 variables. And then it is equal to A matrix, which has 9 entries, plus B matrix, which has 3 rows and 1 column. So 3 rows and 1 column, and then U, and multiplied by X matrix. X1, x2, x3, and then plus sign. So this is all. This is matrix B and this is A matrix. So this is the expanded form of the first equation. So these are x1, x2, x3. These are the state variables. These are the derivatives of state variables, and we have to put 9 entries from these two examples. So let's first put the entries. So I explained in the previous video. So what you do is you only have to put the last row of the A matrix in these type of equations. The last row of the A matrix, and I will explain this why we don't have to put anything here except 1 and zeros. This I will explain after I straight away go from this to this, because this was the promise that you can quickly do that. So how you find this last row? You start from the coefficient of y. So first I am doing this equation. The coefficient of y, start from the coefficient of y and go in the reverse order and change the signs and write down the coefficient. So coefficient of y is 24, change the sign, minus 24. Now coefficient of y dash, or the y prime you can say, the first derivative, is 26, change the sign. Coefficient of y double bar, change the sign. And then you put 0 here, 1 and 0, 0, 0, 1. So this is your matrix A. Very simple. So you always find like this. And I will explain this when I finish with this. So then I will explain again. Now B, you put 2 zeros and then the coefficient of U, which is 24, and do not change the sign. And you will see in a minute why we don't change the sign of this. Because we bring all the terms to the right hand side, so the sign of these will change, but this is already on the right hand side, so no change of sign. So this is your first state equation. So we have A and B, that's it. Now we have to find C as well. So that is the output equation, y equals cx plus du, d is 0, so I just write y equals c. So c has, as you can see, 1 into 3, 1 row 3 columns, something like this, and then we have x1, x2, x3 plus 0, or you can write like this if you want. Now what are these entries? So the first entry is always 1 and the rest are zeros. And this is what I am going to explain now, and I will explain this first, why these 1s and zeros are coming here, and then I will do this equation. And there is a difference in this equation, because in this equation we not only have u, but we also have a derivative of the input, du by dt. So how to handle this? This we will do after I explain why these are 1 zeros and 1 zeros here. This I have already explained, so let's do that. So now what we are going to do is, I am actually going to do whatever I did in the previous video. This is the short form of that derivation, but this is easy for someone who don't want to watch that video. So this video will be a complete tutorial for those guys. So let me explain this, how we got 1 zeros and why we don't have to write anything here. So let's start from this. So write this given equation, given differential equation, so that the highest power is on the left hand side. So I write y triple dash equals, and take all other terms on the other hand side, but be careful when you are in the exam that you start from the y term first, and this will be clear in a minute. So we start from the first term, so minus 24y minus 26y. We should be consistent with how we write y, so just y like this, y dash, and then minus 9y double dash. Because this is already on the left hand side, therefore we did not write any coefficient here, and you will see in a minute. No, and then this 24u is already there. And the way why we write from y is The reason, because the solution of this equation is y. What is the solution? Because this equation is a differential equation in y. So if we find y is the solution. So now we are taking the solution of the equation is equal to our first state variable. So this is important, that we are taking the solution of the equation equals to the first state variable. In a control system, you can choose state variables according to your own choice. The only thing you have to remember is, which I have explained in the previous video, that those state variables should be linearly independent. And the good news is, and the student should note this point, that if we take x1 as the first state variable, the derivative of x1 is not dependent linearly on x1. So therefore we can take the derivative of x1 as a second state variable, and this is a very helpful fact, that we can actually take the derivative of a state variable as a second state variable, and this is what we are going to do here. So, and that will make our process very easy, and you will see how. So first of all, y dash, which is equal to x1 dash, and we take it as a next state variable x2. Similarly, y double dash is equal to x2 dash, and which is equal to the next state variable x3. And instead of these dashes in state space, as you can see that on the right hand side we have dot. So I am changing this dash to dot. There is no difference. They are exactly the same, the derivative, but we use dots. Similarly, xy3 dash equals x3 dot, the derivative of this one. And we don't have to go even further. We don't have to take the fourth state variable, because we only need 3. And now what is the value of x3 dot? x3 dot is this whole term. So we have to put this x3 dot here so that we can get the value of x3 dot in terms of state variable. Now this is the point where student makes most errors. When we are writing x3 dot, on the right hand side, when I am writing this equation, so we have to use only the state variables on the right hand side, no dots, because if you look here, there is no dot on the right hand side. So therefore, start writing this minus 24, instead of y, we use x1, very simple, straightforward, there is no confusion. Now here is the point where student makes error, minus 26, instead of y bar, which value should I use, this or this one? Dot or without dot? So always use the state variable without dot, so x2. Similarly, minus 9, y double bar, use this one, x3, plus 24u. Now we have everything we need to write the state equations and to understand why these 0 and 1s are coming here. We are ready to do that. So how? So first, this equation I will write here so that I can delete all this, but first I just move this to the right hand side, but in a way as these are written in the state equation. So what I will do, I will write x1 dot first, x1 dot equals to x2, then I write x2 dot because of this form. So what is x2 dot? x3. Then I will write x3 dot, which is basically this whole equation. So I will write a little bit, squeeze it down, minus 24x1 minus 26x2 minus 9x3 plus 24u. So now I can delete this. Now we are ready to write this in the matrix form. So now if you look at these matrices, So the only thing you need to understand is how matrix operation work. When we multiply this matrix A with the matrix x1, x2, x3, how this operation, matrix operation multiplication works. So this is the only thing you should understand. So when I multiply these two, so what I am doing is, I am multiplying first row with first column, and I will get one number, only one number. When you multiply these two, the answer will be only one number. Then I multiply this row with this column, another number. This row with this column, and add the corresponding entries, and one number I will get. So I hope you understand this. Once you understand this, then you will understand why these 1s and 0 and how these 1s and 0 will come here. So now look at this equation, x1 dot equal to x2. So what should I write here in these three entries, because we know it has three entries. So what should I write here so that when I multiply this whole row with this one column, I only get this thing, x1 dot equals x2. So the only way is to put a 0 here, 1 here and 0 here. Because 0 multiplied by x1 will be 0 plus 1 into x2 is x2, which we need, and the third will be 0. So this is the only way. Therefore this 0, 1 and 0 comes here. So because we have derived the equation, and after the derivation, we are just writing the derived equation in the matrix form. We are not doing anything from our own. We are just writing whatever we have got into matrix form. So this is how we can only write this in the matrix form if we put 0, 1, 0 here. Similarly, x2 equals x2, sorry, these are dots. These are dots because x dot, you can see here. So x2 dot equals x3. So what should I write here so that I can only get x3 when I multiply corresponding entries and add together? So the only way we can do is 0, 0, 1 because x3 is at the end. So first two 0, and this, because when these two matrices will be like this, there will be three entries here, plus it will be like this, and these two there are only three entries here. So when these two matrices are equal, it means their entries are same, exactly same. Their order is exactly same. So when we multiply these two, we get three entries, x1 dot, x2 dot, x3 dot. So therefore, what should I write here in the second row? 0, 0, 1. And in the third row, what should I write so that I can get the value of x3? Because x3 is the third row. So this is we are going to do next. So I hope you understand this concept. It's very simple year 12 concept, but some student might have forgotten this thing. And now, what should I write here? If I write the same thing here, minus 24, minus 26, minus 9, because this is multiplied by x1, first column, first element with the first, second with the second, third with the third. We add these together, we get x3, this part of x3, and plus 24u. How to get 24u? Because we are in the third row, so we can only put 24 in the third row of matrix B. There is no other way we can put 24, because x3, it comes in the value of x3, so therefore this is 24. So now you understand how these 1s and 0 come in this equation. Now coming to output equation, it's very simple. We have y equals x1, and you can see that in order to get y equals x1, we have to put these two 0 and the first entry should be 1. Otherwise, we won't be able to satisfy this equation. So for y equal to 1, 0, 0, this is the only way we can write the matrix C. So now I hope you understand why these magic 1 zeros are in this, always in the equation when you are solving these equations. So now this is it for this. Now you understand how to convert this. The last thing in this video is how to convert this differential equation into state space when there is a derivative of input. There is another term. So I will not write everything. I will just make the matrices A, B, C, D. And what you need to do is, because we have a derivative term, so I will just delete everything, because now we are solving this equation. Okay, so how to handle these derivative terms? So in the first video, as you might have noticed, that I actually derived the equations, and from those equations we were able to devise a method that we can only change the coefficient of y and the signs of the coefficient of y and write it in a specific order. Similarly, you can also derive an equation for these kind of equations, and that I am not doing here. So once you have the concept of how to derive one type of equation, you can do it yourself. What I am going to do it today is just to show you how to handle these type of equations when you are transferring from differential equations to state space equations. So there are two matrices which are going to be changed in this type of situation. One is the B and one is the C, and the elements of these matrices come from the derivation, which I am omitting, but how to write the elements, this I am going to show you. So the matrix B, first let's write down the other matrices as well, so that we completely go from differential to state space equation. So the matrix A for this equation, the second one is, start from y, go in the reverse direction, coefficient of y's, and then dy, and then d double the second derivative of y, and change the sign only in the third row. So minus 5 will be here, then this will become 7, and this will become minus 3. And because the order is only 3, so we don't have any place left. So we don't have to put this the coefficient of the highest derivative. And as you have noticed that when we derive the equation, this was on the left hand side. Now the rest again, we put 0 here, 1 and 0, and 0, 0, 1. So matrix A for this equation is in the similar fashion. Now matrix B. So the way we write matrix B, when there are coefficient of u as well as there is another derivative of the input, then we put the last row 1 and the rest 0. In this example, we took the coefficient of u because there was only one coefficient, u. When there are coefficients of u and some other terms, then we put 1 here, but in C matrix, in this case, when we made the C matrix, we put 1 here and then 0, 0. But now we are not putting 1 here. We have to fill this C matrix in the similar manner as we filled the third row of the A matrix, but for u instead of y. So now this C matrix is filled with this, so you have to go again in the opposite direction, starting from the coefficient of u, but in this case you will not change the sign. So this is the thing you should remember, because u is already on the right hand side. We change the sign of this because we took these terms on the other hand side. Similarly, when we derive equations for these kind of differential equations, which I am not doing here, so we have to take this on the other side. So therefore the coefficient, the signs of the coefficient will not change, but we will do in the similar manner. Start from the coefficient of u and go towards the derivatives. So what is the coefficient of u is minus 20, and the first derivative is 6, and the rest of the term is 0. So this is the way you find the matrices A, B, C for these kind of differential equations where you have derivatives of the input. So this is it. Now you can write it down in the same manner, expanded form. So I hope that you like this video. If so, please hit the thumbs up button and subscribe to my channel if you are interested in control system videos. I also make videos about other topics like technology tools, project management tools, latex software, and these kind of things. So subscribe to my channel and hit the bell icon so you don't miss anything. You could be the first to watch the videos whenever I post a new video, which I usually do on every Friday. So thanks for watching. See you next time.